Good morning and good evening, and across the audience who is watching my video. Many thanks for taking your time to watch my recording. I'm going to present today about the quantum CloudOps. It's basically about the future technology that is coming up, which we are going to envision tomorrow in another, maybe in max of another 5 years. So we'll be saying more about this quantum processing, quantum technologies, quantum. There'll be a revolutionary coming up which we have to be prepared for ourselves. Hence, I'm taking this opportunity to give some insight how it can be and what we can be achieving more in future. And let's welcome you all and let's dive into the presentation. It's basically this is more. I just want to cover up my last that's one line. It's basically to see the quantum computing with basically we have our cloud infrastructure, we have our DevOps. Now with quantum technology coming into the place, how this amalgamation can revolutionize the whole computer processing, the computer technology, and the it may even come to our everyday day-to-day life. This impacts. That's the intent of this all. Before I go into this, and I would like to take a small opportunity to explain what is this quantum technology and everything. The processing, it's coming from like physics, actually speaking. Right now we have our traditional, I will call it as a conventional processing, which is basically our computer basically is a binary. It's a 0 1. One of the state will be there, and hence we'll be processing based on that. But in quantum, it has the small unit of work is called qubit. It basically has both the values of 0 and 1. It simultaneously can be in 0 and 1. That is called as a qubit. And but in case of a conventional or traditional, we'll have either 0 or 1, the binary. Hence, based on that 0 or 1, the processing logic will happen. But in quantum, being in position of both 0 or 1 at any time until we measure it, that is called as a superposition. And that superposition that makes quantum to really give the the upliftment of processing parallelly multiple tasks. And that really gives us robustness of this processing technology. And that's where many companies are investing on this. The fundamentals of where it started with physics. And now they're putting a lot of research projects so that we can really leverage that processing technique and make the complex processing that we really not even with this AI, the complex processing. So we have the technology is evolving, but if the underneath the processing technology, like the processors are not incapable, we are going to hinder our technology. That's the reason if the quantum processing comes in place and with the AI, we are really going to revolutionize this whole thing. That's the intent of where this whole exercise is going on. Along with it, even the security. Right now, we have a security with the conventional approach of encryption algorithm, but thinking about the quantum technology applying on the top of it, the security will really increase the 10 folds or 100 folds. So the chances of getting a threats will get reduced drastically because it can really envision. For example, I'll go more detail in the examples so that you can really understand. I have a small example to going forward how this security or a processing, how this parallel processing is happening with the quantum, and how we are getting benefited out that. I'll go with it. The other thing which I want to talk about is the innovation catalyst. It will even help us to that we could not dreamt that hey we can do this type of complex processing with this quantum. We can really feel confident. Yes, we can even achieve that one. That's one of the security. The other one is the performance, and the other one is the new innovation. It gives a foundation for us to think about some innovation that we never could able to dreamt about. That is the intent of the whole quantum. Let's move to the next slide. Quantum. Sorry, the hybrid architecture. So we have our cloud infrastructure currently, and we have our CI/CD pipelines, which were original DevOps, and then we move to the cloud. Now everything is on cloud. Now we call it as a CloudOps. Tomorrow, I think maybe it may be called as a quantum ops or anything. But the point is, in quantum, the main important is unit, processing unit. Basically, so the qubit I'm talking about. It will enable us the foundation that is being that is laid on top of which quantum is built. That will really help us to really execute complex quantum algorithms leveraging the power of superposition, the superposition which I was talking about, having been in both 0 and 1 at the same time. That's a superposition which is called in quantum. And the other one is entanglement. These are the concept where I can example, like I'll take more time. So in quantum, basically, generally we have our 0 1 processing, but in quantum at a given moment of time, a, a state can be in 0 and 1 both, and it leverages both the state and to process, and that is called superposition. And that small unit of work is a qubit. Okay. Now think about when a chess player, or when you're playing a chess. Generally, when I play chess or anyone, I can really envision or I can think about the 10 moves my opponent can think about it. Right? He may be doing this, or if he does this, I may need to do this. If I do this, I may need to do. There are about 10 combination max I can think about. But think about if for one of the 10 position, if it picks, what are the other possible 10 options that can come? I only can think once he moves. But in quantum, being in state of the superposition, what is advantage is if the opponent takes one of these 10 position, what are the other 10 combinations that can come? And from the 10 position, what are the 10? So it really takes a whole bandwidth of combination and then process it. And then it will give us a result. Hey, this is something that is coming up, which is a future risk. That level of bandwidth of processing is what is achieved, can be achieved. That is called as a complex processing. That level of thought process or processing is enabled in the quantum. That if we know, apply this processing to security, you are able to envision for certain security threat. But think about if that security threat comes up, what is the other thing that can come up with this? If there is another one, what? So thinking ahead of multiple combination with this quantum processing will really help us to really take a proactive step how we can make these threats not coming up from a security, cloud infrastructure, operations management point of view, or even in financial, or even in medical, everywhere. You can think about in everywhere, if you look really apply, if you increase the scope of your bandwidth of the different else conditions, wide span, then you can really think about what is the best approach for me to take. Hence, that complex processing is not allowed because of the way we are currently, the current processors. But with this quantum processors, we can take that leap and we can really go forward and take more steps and take a proactive step now for the future that is coming under this. That's the intent of the processing unit. The classical infrastructure basically is about talking about our cloud infrastructure. Currently, we have a cloud infrastructure that delivers the conventional computers task and system orchestration right now, right? Applying this, we would like to leverage the same approach, the DevOps or CloudOps, but apply on top of it the cloud, the quantum, and so that we can have the load balancing properly, distribute the workloads with this integration of the quantum and the classical infrastructure. We can really, what is the benefit we can reap is we can really do the workload distribution of and with the quantum and classical optimal performance. And the other one is with this small integration layer, we can even, it has the advanced translator, workload schedulers, and real-time processing system that unify the computer algorithms execution also. Basically, the quantum and the classical, both if you combine, you really getting a very good benefit of, for example, the workload balancing, operational management, everywhere. I'll go more in deep where I can explain you in a pictorial how the benefit, the investment, how the investment is more, but what is the benefit out of it we get more and out of this investment. I'll go in my future slides. DevOps, no, I'm sorry, my mistake. Now coming to we started with DevOps and then we moved now to call as a CloudOps. Now think about what is the transformation we need to do in order to be prepared for our quantum. Basically, we need to upgrade our CI/CD pipeline so that we can reap the benefit of, for example, quantum algorithm deployment and testing. We need to make our CI/CD pipeline so that we can deploy this new set of quantum algorithm and testing. Observability. We have this log metrics and everything for our observability to make our operation like simple. That need to be enhanced for quantum. The other one is the operations models, right? We have a lot of operation models that were defined for our current DevOps or CloudOps, on-prem or on cloud. that need to be enhanced, so that people need to be trained, so that to understand how to manage these operations for the quantum technology based applications. Then automation. We do a lot of automation for our systems, to run automation to make everything more smoother. That automation now need to be enhanced for quantum. We need, so it's more of skill development, enhancing the existing processes that we define, which are stabilized. Now we know how we can make this APIs, for example. We need to know how to build an API for a quantum processing. We need, because it cannot be same way as that, because quantum does more faster. So we need to change the way of your, I feel even the programming languages like Java, they may even change with the quantum technology coming up. The way the multi-concurrent processing, the multi-threading, everything, the implementation will change. In the similar way, every technology will have its own change or adaptability because of this quantum coming up there. And so we need to transform, be prepared, and make ourselves upskill, be prepared for the new approaches for the operation, new approaches for the CI/CD, or new way of thinking of an observability, so that we can get more logs and do the data analytics to take the proactive steps. This is basically how it can impact the existing DevOps. The key industries that benefit from, sorry, my mistake. The key industry that really that benefits from this quantum, this basically is the security. Because developing the quantum resistance and encryption protocols to secure sensitive data against future quantum attacks. Cryptography. Basically, it's security. That is one of the key factor that will be benefited from this, because it can really think about future combinations of threats that can come, and it will help us a lot to reduce this cyber tech attacks coming down. The other one is the algorithms, AI algorithms. We built AI algorithms with the current existing processor technologies. Think about quantum is coming in. So we definitely need to change this AI algorithms so that we can leave the benefit of this parallel processing. That will be an impact. The other thing that will be major impact is on the pharmaceutical. But right now, for example, in medicine need to be come out of the market. It has to go a lot of things, clinical studies, everything. So one medicine to come out, it may take years, but because they don't have the liberty to do the complex processing now, they do the incremental steps, sequential step. But with this quantum, they can do the concurrent execution of these studies. They can do everything like multiple molecular combination to see where is the impact coming up. Time will come down, hence the clinical study will come down, and that will really help us to give, even it will even break through some of the complex molecules and combinations, so that with this quantum, and that may even bring some new innovation. Maybe even we may get a medicine for cancer or something. But basically, it really helps us to break through some of the innovation that we never dreamt about with this quantum. The other important thing on finance, as finance goes with the data analytics, analyzing the data, predicting the future trends of the market, is all based on the data. And data need to be analyzed, processed, so that we can give the results. We are limited with this conventional, or we can say with this current existing infrastructure. But with this quantum infrastructure, you can really make a difference. It can even predict, if I take this move for this something, what is the future? That based on the organization, or based on the future trends, or based on the past trends of an organization, whether I have to invest. It makes more, not only that, it may bring the combination of AI and with this data analytics, it may even give us a very good decision of where to invest in everything. That maybe that's the intent of where I'm going, is the quantum technology applying on finance will help a lot. Not only from me, investment point of view, it even helps from me this self my portfolio and risk assessment based on this analysis. Whether what should I do? Where should I invest? Where should I not invest? Adoption, basically. How do we adopt this one? So initially, we need to build some POCs, right? Generally, whenever a new technology, we need to build a POCs. For that, what we need to do is we need to upskill. We need to, there'll definitely be a provider, like how we have now Azure, Amazon, Google. There'll be a provider, one of these provider, who will provide us the quantum infrastructure, quantum technology. We need to partner with them, then create a POCs to understand, explore, identify what are the how we can really start. That's the foundation. Then we need to build a hybrid quantum class. Basically, now we have our classical infrastructure, and then we have our quantum infrastructure. Now we need to build an integration phase where you build in APIs based on quantum, integrate with the classical APIs, see how the it's basically like a B2B communication how to establish basically. Understand the POCs, understand the limitations, challenges that we may come, overcome that. And so that is the integration phase. First, build something based on quantum, then see the way how we can integrate this quantum based application within classical infrastructure that we call the current. Classical is like a current or a convention with this classical infrastructure to see what are the challenges we have. And then once we integrate, then we need to come with an automation, how we can mature this integration more seamlessly so that we can know where to build what, which is the best platform for us to build what, and how we can make it, make the benefit out of this integration. Define the workload distribution, basically between the classical and automate the quantum resource allocation, measure and improve the quantum things. This is basically the adoption. You need to adopt quantum to this classical, build the application, integrate it, and then optimize and manage it within operation so that our operations on this integration is more seamless and easy to manage. So as I studied what some of the case studies that are going on or that will come in future is basically one of them is a medical, where I can see that a lot of companies will really put investment on this quantum so that they can make their medical study more faster. That is one thing. The other one where the investment will go is all these cloud providers will invest a lot on how do we make easy provisioning of this quantum infrastructure so that they can invite more customers to them so they can get the customer base. So there will be a lot of investment on that. The other one is the drug discovery, which I just talked. And the last one is how do we, it's more to the applications. In a given application, how do I leverage where I should put my investment on which area of an application in a classical infrastructure and where should I leave the benefit of quantum? It's not like everything I built on quantum. It may come with a more cost. So there should be a distinction between within an application, which is my requirement, where I may need a complex processing and where I don't need a complex one. That distinction, if you can make, that level of design, level of distinction, if you make it, you can really benefit. But honestly, if you don't put a little thing through, you're putting everything in quantum, you may have more investment. If you put more on the classical thinking not required of quantum, then you may not reap the benefit of complex processing. So what most of the applications when we now new start when the quantum is already matured, the more critical part is how do we differentiate between where we need to build and deploy our applications. Is it a classical or and how do we integrate this? This is another a new set of design